In this video, we're going to solve some problems with a current carrying wire. Okay, so let's set up a scenario. We're going to draw a diagram below which is going to show a metal rod that is free to roll along some metal rails. Now these metal rails are parallel with each other. So here are the rails, here's the rod, and here's a magnetic field that they're all existing within. This is then, the rails are now connected to a power supply, and they're free to roll over them. Okay, so as it says, the rails and the rod are in a magnetic field which is going into the page denoted by the X's. The ends of the rails, as is stated, are basically attached to a power supply of 12 volts, so I'll put that on the diagram. Now conventional current applies, flowing from positive to negative. Okay, so let's build our question. Okay, so basically we're going to state and explain what happens to the rail when the power supply is going to be switched on, or what happens to the metal rod when the power supply is going to be switched on. We're also going to be asked to explain why this happens. Okay, so let's look at the diagram. We know the power supply is flowing conventionally, so we're going from positive to negative, which means it's going from right to left at the top and left to right from the bottom. So it's going to be flowing through the rail and then coming down the rod and then back to the power supply. If I use my right hand grip rule, my thumb will be going down the rod, which means my fingers will be going to the page on the left of the rod. So let's note them going into the page with some little X's. Just like that. Okay, which means on the opposite side, it's going to be coming, the field lines are going to be coming out of the page. So what this means is that on the left hand side, using the right hand grip rule, we're basically going to have the lines going into the page on the left of the rod. This is in the same direction as the magnetic field, and as a result it's constructive. They add together. This produces a large force or a large field. To the right of the rod, what we've basically shown is that the field lines are coming out of the page. Now obviously if they're coming out of the page, this means they're going in the opposite direction to the magnetic field lines, and as a result they're destructive. They cancel out. We get a smaller field. As a result of this, the rod moves from a large field to a small field, or to the right from the large field to that small field. Okay, let's look at question B. So in this situation, we're going to state that if the wires are 18.5 times 10 to the negative 2 meters apart, and the rod is 25 times 10 to the negative 2 meters long, we're going to calculate the electromagnetic force experienced by the rod if the magnet's strength is 0.85 times 10 to the negative 3 Tesla, and the circuit's resistance is going to be 35.4 ohms when the power is switched on. Okay, so let's look at how we would solve this. Alright, so let's put down what we know. Well, we know our magnetic field strength, which is 0.85 times 10 to the negative 3 Tesla. And we've got that from the question. We know the length of the rail. The length part of the rails is 18.5 times 10 to the negative 2 meters, and the length of the rod is 25 times 10 to the negative 2 meters. We also know that the resistance is 35.4 ohms, and we know that the voltage from the power supply is 12 volts, and we got that from the question earlier. Now we've got two lengths. Now we need to work out which length to use. Now this is the length of the rod. Now the points where I've shown X there, they are not in contact with the magnetic field, with the electronic field. So we only use the distance that the rails are apart for the length. Now we know that the force can be calculated using BIL, but we don't know what I is. However, we do have a resistance and we also have a voltage. So we can use the formula I equals V over R to calculate what the current's going to be. So here's I, 12 divided by 35.4, which means that the current is going to be 34 amps, 0.34 amps. So now I can substitute this into my question. So I've got my field strength up here, I've got my current, and I'm going to be using the rails because these are the only ones where the current is actually flowing. Okay, so 0.85 times 10 to the negative 3 times 0.34 times 18.5 times 10 to the negative 2. Put all that together and I find out that my force, which is acting on the rod, is 5.4 times 10 to the negative 5 newtons. Thanks for watching.